Welcome to the DIY Honda Garage channel. DTC P0172 signifies that the fuel system of the Honda CRV from 2011 to 2016 is running rich, which means there is too much fuel being injected into the engine compared to the air. This condition can lead to poor fuel economy, increased exhaust emissions, and potential damage to the engine and its components if not addressed. The fuel system's components involved in addressing this DTC include the mass airflow MAF sensor, the oxygen O2 sensors, the engine control module ECM, and fuel injectors. These components work together to manage the air-fuel mixture entering the engine for optimal combustion. The MAF sensor measures the amount of air entering the engine, while the O2 sensors monitor the exhaust gases to ensure the right fuel-to-air ratio. It's crucial to follow the outlined troubleshooting steps systematically to accurately diagnose and resolve the underlying issues contributing to the P0172 code. The error code P0172 indicates that the fuel injection system is too rich, meaning there is an excess of fuel in the air-fuel mixture. This typically involves the mass airflow MAF sensor and the oxygen O2 sensors, which are located in the engine compartment. The MAF sensor plays a critical role by accurately measuring the amount of air entering the engine, which is essential for the engine control module ECM to calculate the appropriate amount of fuel to inject. If the MAF sensor provides inaccurate readings due to contamination or malfunction, it could lead to an overly rich fuel mixture. Additionally, the O2 sensors monitor the exhaust gases to adjust the fuel mixture, and if they are not functioning properly, this can exacerbate the issue. Accurate diagnostics for code P0172 require careful observation of these components and the engine operating conditions. Several factors could be causing DTC P0172 to trigger. Issues with the mass airflow MAF sensor can critically impact how much air is detected entering the engine, leading to a significant imbalance in the air-fuel mixture. Additionally, if the oxygen sensors are malfunctioning, they may fail to transmit the correct exhaust gas information to the ECM, which is vital for the fuel trim adjustments. Another common cause involves leaky or malfunctioning fuel injectors, which may be delivering too much fuel to the combustion chamber. Furthermore, aftermarket components in the fuel system could cause discrepancies in sensor readings or fuel delivery, contributing to the rich condition. Addressing these underlying issues is crucial for resolving the P0172 code effectively. When DTC P0172 is present, drivers may notice a variety of symptoms that indicate a problem with the fuel system. One of the most noticeable signs is poor fuel economy, as the engine is burning more fuel than necessary. Additionally, a strong fuel odor may be detectable, signaling that excess fuel is not being properly burned during combustion. Rough idling is another symptom often reported, caused by an imbalanced air-fuel mixture that disrupts engine performance. In some cases, the malfunction indicator lamp, MIL, may illuminate, indicating the need for diagnostic attention. Observing these symptoms early can help in troubleshooting the underlying issue before it leads to more significant engine damage or performance loss. In the first step of troubleshooting DTC P0172, the technician should start the engine and allow it to idle without any load in either park P or neutral N. Using the HDS or Honda Diagnostic System, check the air-fuel feedback short-term fuel trim AF/FB/ST fuel trim values. The specific threshold to look for is less than 0.79. If the values are not matching the threshold, this indicates that the AFFB is excessively low which can confirm an issue and prompt the technician to go on to the next step. Conversely, if the AFFB values are acceptable, further diagnostics would still be necessary to determine potential underlying issues that may not have set off the DTC yet. In this troubleshooting step, the technician reviews the onboard snapshot captured by the Honda Diagnostic System, HDS, when the air-fuel feedback short-term fuel trim was at its lowest point. It is important to record various parameters such as engine speed, vehicle speed, relative throttle position sensor, and accelerator pedal position sensor. The technician should then drive the vehicle under specific conditions to see if the recorded parameters yield different results. Monitoring AFFB while driving helps to determine if the low readings were consistent or if they were solely during idle conditions. This can provide valuable insight into the behavior of the fuel system under different operating conditions and assists in pinpointing the exact moment the problem arises. For troubleshooting step 3, the technician should begin by removing the mass airflow, MAF, and intake air temperature, IAT sensor. Inspect these sensors for any debris such as lint, bugs, or other foreign objects that may impede their function. Debris in the MAF sensor can lead to erroneous air measurement, resulting in a rich fuel mixture and triggering the P0172 DTC. If debris is found, it should be carefully removed, and a vacuum cleaner can be utilized to clear out the air cleaner housing. After cleaning the sensors, they should be reinstalled. If no debris is found, the technician will then proceed to evaluate the fuel pressure in the next step, as the MAF sensor's cleanliness directly impacts the fuel management system. In this crucial step, it is important to measure the fuel pressure while ensuring that the conditions for air-fuel feedback, short-term fuel trim, are at 0.79 or less. The acceptable range for fuel pressure in this scenario is between 330 to 380 kilopascal, which is equivalent to roughly 3.4 to 3.9 kilogram per centimeter, or 48 to 55 psi. If the fuel pressure falls outside this range, this can lead to either too much or too little fuel being injected into the engine, resulting in a rich condition. In such an event, the technician must replace the fuel tank unit to restore proper fuel pressure. Once this is accomplished, the technician should proceed to verify the repairs made to ensure that the adjustments have addressed the P0172 issue effectively. In this step, the technician is tasked with holding the engine at an RPM of 3000 until the radiator fan engages to create a stable environment for testing. It's vital to ensure that the engine coolant temperature, ECT sensor, is above 158 degrees Fahrenheit, 70 degrees Celsius, while the vehicle is in park or neutral N, and all electrical loads are switched off. The goal is to monitor the MAF sensor's readings at 2,500 RPM using the HDS. The expected values for the MAF sensor should range between 7.0 and 8.6 grams per second, G per second. If the readings fall outside this threshold, it indicates that the MAF sensor is malfunctioning or there may be issues with the air cleaner assembly. Correcting these readings by inspecting potential damages or replacing the MAF IAT sensor is critical for continuing the diagnostics process effectively. At this point in troubleshooting, the technician should again start the engine and let it idle before gently pinching the positive crankcase ventilation PCV vacuum hose. By pinching this hose, the technician is able to observe the behavior of the air-fuel feedback short-term fuel trim values while monitoring the vehicle's performance. The goal is to confirm whether the AFFB levels remain below the threshold of 0.79 during this testing. If the AFFB levels are acceptable, it indicates that the engine oil is in good condition and is not contributing to the rich fuel condition. On the other hand, if the AFFB values are too high, it strongly suggests that the engine oil may be contaminated, which would require replacement along with the oil filter. Completion of this step is necessary before moving to inspecting other components. In this troubleshooting step, the technician prepares to replace the fuel injectors with known good ones from a separate vehicle or stock of parts. This step is necessary to determine whether faulty fuel injectors are the source of the rich condition, causing the P0172 code. After installing the replacements, the technician should operate the vehicle under the same driving conditions that previously yielded the low air-fuel feedback, short-term fuel trim value of 0.79 or less. Monitoring the AFFB values with the HDS again helps confirm whether the injectors were indeed the cause of the issue. If the values remain low after replacement, it indicates that the injectors were not at fault, and the technician should proceed to the next step for further diagnosis. Step 8 requires the technician to replace the AF sensor, which is critical for accurate fuel mixture adjustments, with a known good sensor. The AF sensor monitors the ratio of air to fuel in the exhaust gases and plays a vital role in optimizing engine performance. After installing the new sensor, the technician should operate the vehicle under the same conditions that were previously established when the low air-fuel feedback short-term fuel trim value was recorded. Using the HDS again, check to see if the AFFB values improve and return to normal levels. If low AFFB values persist, this points to a deeper issue in the vehicle's fuel management system that still requires diagnosis. If values normalize, the replacement was successful in rectifying the issue impacting the fuel system. For this troubleshooting step, the technician needs to assess the fuel in the tank. It's especially crucial to recognize that if a misfire occurred shortly after refueling, a fuel-related issue is likely. The technician should drain the fuel tank and replace it with known good fuel, ensuring that factors such as unknown additives or impurities are eliminated from the equation. Following this fuel replacement, repeat tests while monitoring the AFFB values under the same driving conditions as before. If low AFFB values continue, it suggests an issue unrelated to the fuel itself, which may prompt the technician to explore options such as substituting a known good engine control module, PCM, to verify if the current module is malfunctioning. This thorough examination is critical in isolating the root cause effectively. Once the potential issues have been identified and addressed, final repair verification is essential to ensure that the problem is resolved. The technician should start by turning the ignition switch to the on position and resetting the engine control module, PCM, using the Honda Diagnostic System, HDS. Following the reset, it is crucial to perform the idle learn procedure, which allows the PCM to relearn idle settings based on current vehicle performance. After these actions, the engine should be started and allowed to idle, while AFFB values are again monitored. Holding the engine at a stable RPM until the radiator fan engages is also necessary during this process. Ultimately, confirming that AFFB values return to an acceptable range indicates successful troubleshooting, thus closing the case. To prevent DTC P0172 and maintain optimal fuel system performance, regular preventive maintenance is crucial. One effective measure is routine cleaning of the mass airflow sensor to eliminate debris buildup, which can inhibit accurate airflow measurements. Regularly checking the quality of the fuel being used in the vehicle can also help avoid fuel-related problems that might contribute to a rich condition. Timely changes of the engine oil, according to the manufacturer's recommendations, are essential in maintaining engine health, as contaminated oil can affect various engine components and their interactions. Furthermore, using high-quality components for repairs, whether involving the fuel system or engine performance parts, ensures better longevity and reliability of the vehicle. Following these preventive measures can significantly reduce the occurrence of related error codes and enhance overall vehicle efficiency. In conclusion, DTC P0172 reveals significant issues concerning a rich fuel condition that can lead to impaired engine performance and increased emissions. A systematic diagnostic approach is vital for accurately pinpointing the underlying causes, which may range from MAF sensor contamination to faulty O2 sensors and potentially defective fuel injectors. By adhering to a methodical troubleshooting process and verifying repairs rigorously, technicians can effectively resolve this issue and restore the vehicle's fuel system functionality. Additionally, understanding the importance of regular maintenance practices can go a long way in preventing the recurrence of such DTCs. Keeping the vehicle in top shape not only enhances performance, but also fosters longevity and reliability over time. Please like and subscribe to the channel. See you next time.